Today we're going to talk about nuclear fusion. And our objective for the day is to describe nucleosynthesis and how heavier elements are formed. This presentation is actually going to be relatively short because you guys are going to be doing a lot of practice on nucleosynthesis. Tomorrow, in our next lecture, I'm not 100% sure if this is going to be tomorrow. I think it probably is. We will see though. We're going to continue moving on through the rest of our unit. This is not going to take us very long today. When we talk about fusion, we have to first look at our subatomic level. Okay, we have to understand that there are three particles called subatomic particles. Okay, they are protons, neutrons, and electrons. Okay, we need to know where they're kind of located. So, out in the outer ring, we have our electrons. Also, they're negatively charged. So we are going to, here you go, 0, and then we'll do a plus. So we're going to abbreviate our electrons with a minus sign, just like this. Now, our protons are going to be positive. So we're going to say that our protons are these red ones. If I write directly on them, you guys can't see that, so I'm going to draw them kind of up here. These are protons. And then our neutrons are going to be these little blue ones. Now, it's important to know where they are because they follow very specific rules. Protons, the number of protons actually makes up the element that we are studying, or that the number of protons determines the element. So if we have one proton, it will be hydrogen. If we have two protons, it is going to be helium. If we have three protons, it's going to be lithium. Protons plus neutrons gives us the weight, and electrons are actually what is going to bond with other elements in order to make compounds. When we talk about fusion, we are mostly talking about protons. So we are talking about these red spheres. Protons are going to identify an element, and they're going to change the weight of an element. Now, fusion is the smashing together of atoms or particles. And when we fuse something together, we're going to smash them together. That's how fusion works. Now, how much energy does this process produce? The energy released from the fusion of 1 gram of hydrogen is equal to burning 5,000 gallons of gasoline or 20 tons of coal. So if you think about it, that is a lot of energy. 20 tons weighs a lot. It is a very, very, very large unit of measurement. And 5,000 gallons, I want you to think about 5,000 gallons of milk. Okay? Now put gasoline in there. 5,000 gallons of gasoline. That is how much energy is released from the fusion of 1 gram of hydrogen. That's an insane amount of energy. Now, this is the slide that is going to take us some time. So we have 4 hydrogen nuclei, just protons, is going to become 1 helium, which is 2p, 2n plus energy. So I want you guys to go ahead and work through this. So 3 helium, which is 2p, 2n, becomes 1 carbon. So how we do this, okay, is that we are going to take this 3, and much like math, we're going to distribute it into both places. So now we end up with 1 carbon. So carbon is 6 on the periodic table. Okay, so carbon has 6 protons. Now that's the answer. Okay, and we get energy out of it. Now if we want to take 4 heliums, okay, we take 4 times 2 and 4 times 2. It becomes oxygen because oxygen has 8 protons, and it's going to become 8 neutrons as well. And this will make energy. So if we have 1 carbon, okay, which is 6p and 6n, plus 1 oxygen, which is 8p and 8n. Now we're going to add these together because notice if we distribute our 1's in, it's still going to be 6p and 6n and 8p and 8n on this side. So now we have to add them together. So we add 6p plus 8p, which is going to give us 14p, which will make silicone. And we need to take 6 plus 8N, and that's going to give us 14N. Now, how could you make iron, which is Fe, and it's number 26 on the periodic table? Okay, what we're going to do, there's more than one way to do this, obviously. We're going to take 4 carbon, okay, which has, went up here, 4 carbons. They have 6 protons each, so we distribute these in. We end up with 24. P and 24N right here, plus 1 helium, which is going to give us 2P and 2N. When we add those together, we're going to end up with 26P and 26N, which is going to be our iron molecule, our iron atom. Now, all fusion is it's just putting these together. So we have to follow basic math rules. Okay, you have to distribute the number in first. After you've distributed, then you add. So you follow really. You guys ever heard of PEMDAS? Parentheses, exponent, multiplication, division, addition, subtraction. Okay, you have to multiply before you add. If you were to add these first, it's not going to work. So make sure that you're distributing and multiplying at the beginning. That's all that I got for you guys today. Well, besides this video, so please watch this video. Yeah, then that's all that I got for you guys today. So please stop playing. Now, please make sure that you guys are doing your homework. Please make sure that you're doing your warm-up. Make sure you do your DOL so I can mark you as here for the day. Make sure that you guys are getting your grades up. I have a lot of missing assignments right now. Your grades will be updated this week, later this week. So please make sure that you're doing that. That's all I got for you guys today. Have a great day, Stallions.